Hi, my name is DEE20033. The mole matrix number is 01DE22F1084. Today I want to present about generic skill, question 1 and question 2. Now I want to present question 1C. The question is calculate the value of VP secondary, VRMS secondary, and average if V average is 110 volt. With load resistance RL is equal to 1.5 kilo ohms for a full wave bridge rectifier. So we want to find V average. If follow the formula for the bridge rectifier, it is V average equal to 2 V out per pi. So we want to find the V out, so we put the V out in front, so equal to 2 V out equal to V average times pi. Then 2 V out equal to 110 times pi, and we get the answer 345.58. And then we divide by 2, so we get the answer V out is 172.79 volt. And then we use the formula to find the VP secondary. It is V out equal to VP secondary minus 1.4 volt. So VP secondary is equal to V out plus 1.4 volt. And then we use the V out, we use the value substitute inside, and we get the VP secondary. And then we want to find the VRMS, and the formula is VP secondary over square root 2. And then we will get the answer 123.17 volt. And now we want to find the I average. With the formula is I average is equal to V average per RL. And it is 110 per 1.5 kilo. And we will get the answer 73.33 milliampere. And now it is question 2. Common emitter configuration is shown in figure 1a. If the transistor BC107 used in the circuit is silicon type and beta is equal to 200, we want to calculate IB, ICQ, VCEQ, IC saturation, and VCE cutoff. Here is the circuit from the circuit VCC, and here is RB1, RB2, RC, RE. So the first step, we want to find the KVL for input load. That it is the input load is here, and then we want to use the formula. It is summation of EMF equal to summation of V drops. So is VCC. VCC equal to VRB plus VBE plus VRE. The RB1 and RB2 it is the series form, so we want to plus together, so we get the answers 602 kilo ohm. And we will get the formula like this. IE VCC equal to IBRB plus VBE plus IERE. We know that IE is equal to IB plus IC, and IC is equal to beta IB. So we want to substitute inside, so we get the IE equal to IB plus beta IB, and then we can factorize to get the answer IE to 1 plus beta IB. And then we substitute inside the formula input load, so we will get VCC equal to IBRB plus VBE plus 1 plus beta IBRE. And we want to find the answer IB first, so we put the IB in front, this IB. So IB is equal to VCC minus VBE over RB plus 1 plus beta RE. And then we substitute the value, so we get the answer IB is equal to 30.05 microampere. And then now we want to find the ICQ. ICQ is IC is equal to beta IP. The question, it gives the beta is equal to 200, so we just substitute inside beta IP 200 times 30.05 micro, and we will get the answer ICQ. It is 6.01 milliampere. And now we want to get the third step is we want to find the KVL for output load, and it is here. And it is also same one. The summation of EMF is equal to summation of V drops. And it is VCC equal to VRC plus VCE plus VRE. And it will become VCE equal to VCC minus ICRC minus IERE. So we know that IC is also equal to IE. So we can factorize like this. VCC minus IC times RC plus RE. And then we substitute the value. And we will get the VCQ is equal to 6.778 watt. Okay. Then the next step, we want to find the IC saturation point. For saturation point, VCE is always equal to 0. Because the VCE is from the x-axis. So VCE is always equal to 0. So now we put the from the output loop equation, from this equation, VCE equal to VCC minus IC times RC plus RE. So the VCE we assume to 0, and we want to find the IC saturation, so we put the IC in front, and we will get the formula like this. And then we will find the IC saturation point. It is 0.9.09 milliampere. And now we want to find the VCE cutoff point, and then the IC is always equal to 0. So this also same. We just use the output loop equation, and IC we assume to 0, so 0 times RC plus IE and becomes 0. So VCE cutoff point is also equal to VCC, and is equal to 220 volt. Okay, that's all for me. Thank you.